Hi again, everyone. Hope you're having a good first day. We're about to get into our last session, but first, the answer to the quiz question. The question was, what is the minimum transaction fee on Stellar? And the answer is, dun, 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 100 stroops. Like protocol version, the minimum fee is decided by validator vote. Will it always be 100 stroops? Probably not. That's what it is right now. More on that later. Now, if you took any of these quizzes throughout the day and you're curious if you were one of the first to get the answer right, therefore winning some swag, check the Meridian dashboard in a bit. We're going to be posting winners at the end of each day. And now it's time for the last session of day one's technical track. So we've looked at the nodes that make up the network and at the protocol they run and at an app that leverages the new protocol features to create a truly user-friendly experience. Now it's time for the last piece of the puzzle. We're going to dig in on Horizon, Stellar's client-facing API, which is actually the interface that most developers use to interact with the network. In 2020, the Horizon engineering team built out a totally new architecture that decouples Horizon from Stellar Core. I'll let our next speaker, Eric Saunders, Horizon engineering manager at SDF, explain exactly what that means, but big picture, running your own Horizon node to access the network is about to get a lot easier, which is good for both businesses building on Stellar and for network health and decentralization. Eric, I think they're ready for you. The floor is yours.
Thank you, Justin. Hello, everybody. My name is Eric Saunders. I work on the engineering team on Horizon. And I'm going to talk to you today about Horizon's new architecture and in particular, what it used to be like, why we changed it, and why it's better. And before I start, I want to give a big shout out to the fact that there are many, many people involved in this. This is not my own work. I look after the Horizon team, but the Horizon team is many engineers. And the Stellar Core team has also done a lot of work to make this possible. So this is a group effort over many months. All right, so we're going to talk about the history of Horizon's architecture and how we got here. Then we're going to talk about speed and how to make things much, much faster than they are today. And then finally, I'll go through what the new architecture looks like and what the consequences are for you as a user of Horizon. So Horizon, what is it? Most of you probably know what Horizon is if you're coming to my talk, but just as a quick recap, the Stellar network is made of Stellar Core. Stellar Core communicates with itself in a distributed fashion to make the blockchain work. That's how the blockchain rolls forward in time. Horizon is like the doorway to the network. So for most of the ecosystem, almost all of the ecosystem, Horizon is the gateway to the blockchain. It's the way that you find out about what is happening on Stellar, and it's the way that you submit transactions to Stellar to change the world. So the architecture of Horizon is kind of interesting. Horizon communicates with the Stellar Core. That's sort of obvious. It needs Stellar Core to know what's going on. It also communicates with something called the history archives, which we'll come back to. And then maybe the less obvious part is that Horizon looks at Stellar Core's database as well. It gets information from Stellar Core's database, which is an unusual thing. And really what we're changing here looks like such a simple change. We just removed a line from a diagram. We just took away the dependency on Stellar Core's database. But this is a massive change with huge consequences. We're going to go into the details of why that is, how we did it, and the challenges that we faced. Okay, so why am I so excited about this? It doesn't look that exciting on the surface. And indeed, what is the problem with depending on Stellar Core's database? Why did we even go through and do all this work? These are fair questions, and to answer them, we're going to have to understand a little bit more about what Stellar Core does and how it works. So Stellar Core is the blockchain. But then maybe the easiest thing to think about for this purpose is that Stellar Core is really just a state machine. It's a state machine that changes the state of the world, and the world is ledgers. So we have a current ledger, we have a set of transactions, and those transactions are going to be applied to the ledger to produce a new ledger state. So a transaction might be a payment, the payment is applied, your account balance goes up. In the new ledger state, you have more lumens than you had before, for example. And what Stellar Core does is it just does that over and over. It turns a handle and it does it over and over again every few seconds. Ledger comes in, transactions are applied, new ledger comes out. And as we do that application, as we produce the new ledger, a record of that is sent to the history archives and stored for posterity. Now, the actual situation is, in computer science terms, is a bit more complicated than this, because Stellar Core is actually a replicated state machine. And so you have many of these state machines across the network distributed, having to stay in sync with one another. And that's a lot of details and a lot of complexity, but we're not going to worry about that right now because it's not relevant to what we're discussing. Okay, so Stellar Core can replay past transactions. And when it does, it produces something very special, very important. It produces transaction metadata. We call this TX meta, and I'm going to call it TX meta for the rest of the talk. Now, TX meta is really, really important. It describes how transactions actually changed the state of the ledger. And it's stored in Stellar Core's database. To give you an example of why this is important, if you are a user on Stellar and you have an account, you can go and look up your account balance at any time you want. And you could go and look up your account balance in the past and see what it was like a year ago. How much money did you have? But the real question that humans are interested in is not the what, the state. We're interested in the why. We're interested in understanding how our balance changed over time. Who paid me? When did they pay me? When did I pay somebody else? Who accepted my offer? It's these kind of questions that allow us to build a story about what happened with our data. And all of that story depends on TX meta. So this is why Horizon must have TX meta. TX meta allows us to answer the questions that you need to have the answers to if you want to know how and why things actually happen. So the weird thing about this situation is that the TX meta is essential to Horizon, but it is completely irrelevant to Stellar Core. But Stellar Core stores the TX meta in its database. And that is kind of a problem. TX meta is pretty big. It takes a lot of data to describe all of the interactions that led to the ledger changing. And if Stellar Core has to preserve that data for Horizon, then that turns into hundreds of gigabytes of data. Stored in Stellar Core's DB, you have a big database for Stellar Core. The other part, which is maybe most important for the purposes of what we're discussing, is that generating this TX meta is not a quick process. It takes weeks and weeks and weeks if you want to go all the way back to the start of Stellar's history and build a complete record of how everything happened on the network. So that is obviously a problem. If you're a new operator and you want to come up to speed with a full Horizon node that can't answer any question through history, but it takes you 3 weeks to get up to date, that's not a cool situation. Okay, so at this point, some of you that paid attention to the first diagram, you might be shaking your head and saying, why are you even looking at Stellar Core? Why don't you just use the history archives? They record the history, right? And it is a good question. Why don't we use the history archives? Well, Stellar Core deals with the current state. As we saw, it's a state machine, takes the current state, produces the next state, goes from one ledger to the next ledger. And the history archives store history. But the archives do not contain TX meta. And there's a good reason for that. And the reason is TX meta is very large. So the history archives are actually a kind of very clever compressed format. They record checkpoint ledgers. Every 64 ledgers, a recording is made to the history archive. And it is possible to reconstruct the full history of the Stellar network from the history archives, but it isn't easy to do that. In fact, right now, only one process really can do that, and it's Stellar Core. So the way you can think about this is Horizon needs Stellar Core effectively to decompress the history and generate the TX meta, which allows us to answer all the questions that we care about. So Stellar Core, from Horizon's perspective, is a specialized tool to answer these questions and make Horizon actually effective. So just to recap all of that, there's a lot of information here. Horizon really needs TX meta, but only Stellar Core can produce TX meta. So Horizon needs Stellar Core. But the problem is TX Meta takes a really long time to produce. And that makes it very precious. Nobody wants to have to reproduce that and wait another 3 weeks. But it's hundreds of gigabytes of data. So we are in a sort of precarious situation where it's scary to run a full Horizon. So the question really that motivated all of our work was, is this really the way it has to be? Could we do better than this? Can we improve the user experience for operators that want to run Horizon in production? So let's talk about speed and what we can do about it. So we started as a thought experiment with Stellar Core. What if we had a Stellar Core that only did one thing? Right now, Stellar Core does a lot of things. It produces this TX Meta for Horizon, sure, but its main job is to apply to blockchain, participate in consensus, stay robust, all that stuff, do SCP. What if we try to just abstract away as much as possible? So we optimize, we hold everything in RAM that we can possibly hold for speed. We don't bother with consensus or almost anything else, in fact, and we just try and produce TX Meta as fast as possible. So just solve this one problem for Horizon. The thought experiment is, if we did that, how fast could we go? So I'm going to wave my hands here and say a lot of work happened here. There are a lot of details in what happened, and the Stellar Core team worked really hard on this, especially Graydon Hoare. But he went away and thought about this a lot, added a new command line flag to Stellar Core, and did a bunch of testing. And it turns out that this new Stellar Core is fast for TX Meta. So I'm going to call it fast Stellar Core. It turns out that an optimized Stellar Core that only produces TX Meta can process hundreds to tens of thousands of ledgers every second. There's a wide range in processing speed. And the reason for that range is because it's highly dependent on how full the ledgers are. For about half of Stellar's history, ledgers are very, very empty. You can process those at tens of thousands a second. The latest ledgers of Stellar are much busier, and they take longer to process. This is a good thing. It means the Stellar ledger is full. People want to do things with the ledger, but it's more work for Stellar Core and it's more work for Horizon. Okay, so this Stellar Core that we've got, it doesn't do consensus. It doesn't do anything except slurp history data in and produce TX Meta out as fast as possible. And we're going to treat this Stellar Core like a specialized decompression routine. It's a way for Horizon to get TX Meta, and that is all it does. And this is kind of amazing. It's amazing that this is actually possible with the architecture, and it's amazing that we can get this kind of speed. Okay, but there's more. Stellar Core can run really, really fast, but there's another really interesting feature of this problem, which is that producing TX Meta doesn't depend on ledger ranges. You don't have to start at the beginning and go all the way to the end. You can choose a range and produce TX Meta just for that range. So that means we can take, say, 100,000 ledgers, and we can chomp through it with this fast Stellar Core that Graydon's produced, and we can generate a whole bunch of TX Meta for that 100,000. And Horizon can actually slurp that in and put it in its database and tick that off. That 100,000 is done. But we can do that in parallel. So if we have more Stellar Cores, we can just start up more, hand them all different chunks of the history space, and ask them all to start producing TX Meta and feed them back to us. So this is a trivially parallelizable problem. None of these Stellar Cores need to communicate with each other in order to do this work. They just take their task, chomp away. So what that means is the speed of this is really only limited by, well, the original speed of Stellar Core at doing the work, but then the number of workers that you want to produce and how fast you can actually suck all of the data in at the other end, at the Horizon end. So a lot of work had happened here as well, and I want to give a big shout out to the whole Horizon team for this. If you want to hear about all the gory details of what we had to do, please go and look at our GitHub. We have many, many issues that we worked through to make this happen. But the critical fact is we took this away we parallelized it. We did a lot of testing to find out what the optimum ledger ranges were, what kind of hardware we need to run, and how fast can we actually do it. So in the end, the question is, how fast is fast? And the answer is pretty fast. So in 2020, the full history of the Stellar ledger is something like 30 million ledgers. It turns out that if you have a big enough machine in Amazon, we did this on a 32 core machine with 64 gigabytes of RAM. With a machine like that, you can actually do the full ingestion in 1.5 days. This is compared to the weeks that it would have taken you before. And we actually did this at the SDF recently and re-ingested all of our data for our production Horizon instance. So we know that this is just a fact. Again, the details of that test and how we did it are recorded in our GitHub. So the sweet spot here was 24 parallel workers on this big machine. Now you might be thinking, well, that's great, but that's a huge piece of hardware. I can't afford to run that. Well, the key point to take away from this is you only have to do this on the initial ingestion. And you don't even have to do it. It's just if you want to go as fast as possible, you want something big like this. But in 1.5 days time, you're done and you can get rid of this machine and fall back to something much smaller to do the day-to-day trickling in of TX Meta. Okay, so what does it mean for Horizon and the Stellar Core, and what does this new architecture look like? So the first thing is there are a lot of really great consequences for Stellar Core. Recall that Stellar Core was holding hundreds of gigabytes of TX Meta, all of this history that it doesn't care about for Horizon's benefit. Now in the new world, it doesn't have to hold any TX Meta. It's ephemeral. You fed that TX Meta to Horizon and you're done. Stellar Core can get rid of it. So the core database used to be very large, hundreds of gigabytes. Now it is tiny. It's around 3 gigabytes because it's the size of one ledger. Stellar Core cares about the current ledger. It's about 3 gigabytes. So for such a large database that we had in the past, we needed Postgres to look after that and make it atomic and everything. Now that we have such a small amount of data, it's actually possible to hold it entirely in RAM. We can hold that on any reasonable machine. I don't even need a persistent storage for Stellar Core. So the old database was expensive to build. You'd spend weeks carefully building up this TX Meta. After you build it, you probably back it up and you probably store it really carefully, maybe in RDS, maybe with lots of fail-safes. All of that adds cost and complexity to your deployment. Now, in the new architecture, the core DB is not precious. If your Stellar Core crashes, you lose your database in RAM and you start again, it's only 3 gigabytes and the Stellar Core comes back into sync, pulls in the current ledger and it's good to go. So those are the consequences for core. What does it mean for Horizon? So the first thing was rebuilding a Horizon database that was corrupted or had some issue could take many days, especially if you didn't have that TX Meta, if you threw it away. In this new model, press the slide, we could rebuild the whole database in just over a day, maybe even faster with more serious hardware. In the old model, we had to back up and store Horizon's database very carefully. Now, the DB is significantly less precious. It still could be an outage of a day or a day and a half, which is not a good situation, but maybe you run more than one Horizon and you don't worry about it because you know you can recover now. Okay, in the old Horizon, you had fixed rate ingestion. That meant you could only ingest at a certain speed and you just had to sit there and wait until it was done. Now you have this really interesting situation with parallelism. You can boost your hardware, put in as many workers as you can afford, and just get as much speed up as you want. So this is a sliding scale. How much money and how much time do you have? You can adjust that, but to suit whatever your conditions are. And I should say that with that initial ingestion, if you really want, you can run one worker and it will still go much faster than before because it's an optimized fast Stellar Core. But that means that this is strictly better than what you had before. You can still run with just one core worker. Okay, and then the final thing was Horizon was closely coupled to the core database in the past. This is kind of a programmer problem, right? But it's an annoying one. Horizon is looking at Stellar Core's brain, essentially, and pulling out information from that brain. And that makes it very hard for Stellar Core to change what they do or change the schema without affecting Horizon. Now in this new model, Horizon doesn't look in Stellar Core's database about anything. That frees Stellar Core to use its database for itself and focus on its own performance and requirements. It also means as a side effect that Horizon cannot impact Stellar Core's performance with large queries because there are no queries. We're not asking anything from Stellar Core's database anymore. So now we have a clean separation. And this clean separation has a big consequence for production architecture, which we'll talk about next. So in other words, we've gone from this situation with Horizon to something more like this. We're much faster and more agile and much less heavyweight. Okay, so you may be thinking that this sounds great, but it certainly sounds a little bit complicated. Maybe this is harder to deploy. This is not harder to deploy. It is easier to deploy. This was a key requirement of what we were doing. It should be easier than what you had before. So I'll show you two examples of how to get this going. Let's say you're a small operator and you just want to get going and you have one machine. You set up that single machine, you install Ubuntu on it, or maybe you just have an Ubuntu virtual machine. Then you install from packages, Postgres, Horizon, and Stellar Core. And you're done. The whole thing runs on one machine. If you don't want to use Linux packages, you can also do this through Docker. As you can see from the diagram, in this model, we have a captive Stellar Core. I say captive because Horizon is looking after that process. It starts Stellar Core, it communicates with Stellar Core. Stellar Core is just feeding Horizon that TX meta that it needs. As Horizon gets that meta, it stores it in its database, so it has a persistent record. And then it serves the users at the top, the little happy faces, and they're very pleased with your work. This works great for small problems or if you're just getting started and you just want to get the thing running. Now, if you want to do something more serious, you're a bigger player, you want more redundancy, you need something more like this. And this architecture is much more like what the SDF actually runs on our production Horizon instances at horizon.stellar.org. So in this case, we have different Horizons doing different things. Right at the bottom of the diagram, we see ingesting Horizons. These two Horizon instances are only responsible for getting data about the network and feeding it to a database. So they have a Stellar Core so they can communicate and get that fast TX meta. These Horizons do not serve anybody. They're walled off, they're back-end processes, so they're safe from any kind of denial of service or high load coming from user requests. The data is stored in a shared database, and then Horizon, new Horizon nodes at the top here, they're request serving. So their job is to actually answer questions for users. So you have these user-facing Horizon nodes. The really cool thing about this architecture is that the user-facing Horizons do not need to write to the database. They just answer questions. They're read-only. So that means you cannot corrupt the database with your requests or with weird questions that you're asking. And this is pretty safe. You can have as many request-serving Horizons as you can afford on your database bandwidth. And if you run out of bandwidth and your database can't deal with more Horizons and you need more behind a load balancer, you can replicate the database. So here, the dashed line represents replication. We have a read-only replica of the DB, and we can fork off more request-serving Horizons from that replica. So this is only possible because we've decoupled Stellar Core and Horizon entirely. And what it means is you can scale horizontally as far as you like. Behind a load balancer, people see a single Horizon instance, but you can serve hundreds, thousands, millions of requests as much as you want. So this is pretty huge, and this is the recommendation for serious production deployment. Okay, so where are we at? The status is, this is available now. There is an experimental flag in Horizon that you can use to start this up and run it and play with it. We do not recommend you run it in production right now because, as you can see, Bartek and the rest of the Horizon team are busy in final testing. We actually have to use these microscopes to do the tests. Not really. But the final testing is in progress. And we will be releasing this in production in a few weeks. But we want to do a few more things, convince ourselves that it's completely rock solid. And we're going to provide information and documentation about how you transition from a classical setup with these big databases to this new model. So please watch this space, sign up for the SDF mailing list. We'll tell you all about it when it's available. This is the future for Horizon, and we hope it will be a much improved situation for all Horizon operators. Okay, so I just want to say thank you to everybody again, and all the pictures in this slide deck were from Unsplash. This is a really great website for free images. Please go check that out. And I'll take any questions that people have.
Great. Eric, we've got some questions coming in through the QA bar that's on the right of your screen. And if you have questions, go ahead and enter them now. We have about 7 minutes, so we'll get through as many as we can. I think you kind of answered a lot of these questions. They're about the timing. You said it's coming soon. Can you elaborate on that at all?
Yeah, I wish I could. So where we're at now is that we are testing different configurations of this in production. We have a staging server at the SDF where we actually replay the full traffic that our public servers receive. And we want to prove that this works under load and that there are no issues with memory, anything like that. So we're going through that process now. Everything is pretty solid, but similarly to what John Jove mentioned in his talk, we're extremely concerned with correctness. We do not want to provide you with something that could have any issue, and that's why we're still testing. So the answer to the question is real soon now. I think we're probably only a couple of weeks from being satisfied, and then what we'll do is we'll actually try and deploy this ourselves at the SDF and make sure all the kinks are knocked out, and then we'll write the rest of the docs, and then it will be available. So by the end of the year, definitely.
Great. And I think this is about the fact that you can now sort of keep Stellar Core in RAM instead of as a Postgres database. The question is, what's the timeline to deprecate the database, if at all?
Oh yeah, well, so when this new architecture is released, at that point, the database for Stellar Core is deprecated. You don't need a Postgres database anymore.
It's deprecated by default, basically, because of the way that the new architecture works.
Exactly.
So Anthony asks, as a rule of thumb, how much faster will this make Horizon and Stellar Core?
Okay, so there's two things to remember. There's offline mode and online mode here. So we've talked almost entirely about the offline mode. You want to get up to date. You're a new person. You need to slurp everything in, or you had a catastrophic accident and you need to recover your data. That is much, much faster. That's the difference between weeks and days, right? In daily operation, though, what will happen is we'll use one of these fast Stellar Cores to just keep us up to date, but it trickles the data in every 5 seconds. It's not a problem. There's no bandwidth issue, but we didn't have an issue before either. So day-to-day usage will not appear to be faster, but it will be simpler, no database.
And what do you think this means in terms of not just people who are currently operating Horizon, but in terms of increased adoption? Is there a hope that this will lead to more people running their own Horizon node?
Yeah, I really hope that that is what will happen. One of the issues that I think puts people off running their own Horizon node is you need a Stellar Core. Does it need to be a validator? How do you hook these things together? You got 2 databases to keep track of. It's a lot of overhead, as was mentioned in earlier talks today in the dev track, actually. In this model, the idea is that you as a user can think of Horizon as just a single thing. It is Horizon. It has a Stellar Core that it uses for data, but you never really see it. It's a specialized program that starts and is run by Horizon. And so from your point of view, you just have a Horizon and you run it and you have a Horizon DB. And so I think this will be much simpler, and I hope it will encourage people to run their own Horizons to answer the questions that they have.
I feel like when you told me about this a long time ago, you mentioned a metaphor of like omelets and eggs. Do you remember that?
I'm trying to remember it.
I think it was like Horizon is like a chef that wants to make an omelet but can't crack its own eggs.
Right. Yes, exactly. So Horizon is a chef that's always relied on Stellar Core for everything. But now in this situation, it has like a Stellar Core that is available just to crack the eggs. And that means that to run a Stellar Core on your own, you do that for other reasons, good reasons, but not this reason. You run a Horizon to get the answers to questions and to submit transactions. And you run a Stellar Core if you want to participate in consensus, or you want to be able to vote, or you want to make sure that you can have issue or enforced finality on your assets. These are distinct problems, and some people want to do both, some people will not, and we want to make that as easy as possible.
And I think that the next question here is, would it be possible to generate TX meta using a Pi cluster? I think in general, does this change hardware requirements for running Horizon and or Stellar Core?
Yeah, so it doesn't change hardware requirements. You can still run a Horizon with a single Stellar Core, just like you did before. But if you have more hardware, or you're willing to pay for some hardware for a little while, then a cluster is an ideal scenario for you. And then if you're in the other situation where you have a lot of traffic, or you really want your services to be very robust, this decoupling makes it very easy to do that in a safe way. So I think it's a big win for both cases.
Cool. And one final question, this one's from Lee, and it is, how would I build an application consuming TX meta for the public network?
Oh yeah, good question. So we have like a little Easter egg coming as well. I haven't talked about it in this talk, but all of this work was made possible by rebuilding Horizon's ingestion library and modularizing it. And this library is actually a Go library that we're going to be releasing soon with documentation that you could take away and write your own application with. The library does all the heavy business of understanding how to deconstruct and build all the information you need, and then you just go and use it. So the ingestion library will be the future for people that want to build things and bypass Horizon, and we want to encourage that as well.
Amazing. Well, thanks so much, Eric. That's all the time we have. I really enjoyed it. I hope everyone out there did too. I mean, speed, serious simplified deployment. I've got to make the pun, a new Horizon. Right? If it hasn't already sunk in out there, I think it's going to be huge. Also, if you can believe it, that's a wrap for our sessions for day 1 of Meridian.